All right, hi everybody. So we're going to finish up some of these questions here. Now, the next two questions are going to require completing the square. So I'm going to kind of do it quickly. So again, remember when we complete the square, we separate out the x and the y components individually and move anything that's not going to be completed to the other side. So now we factor out just the numerical GCF. In each of those components. And remember, to complete the square, we divide the b value by 2, and then we square that value, so plus 1 here. Doing it here would be a plus 9. However, when I add it to the other side, I have to be cognizant of the fact that I actually didn't add 1 essentially, but I added 4 because of the coefficient I factored out. And then add 9, I actually should add 36. So once I do that, I have the equation 4 times the quantity x squared minus 2x plus 1 plus 4 times the quantity y squared plus 6y plus 9 equals 60. Now, with that, I can factor both of these components. And before I even, continue with the problem, I think it's very clear that this should be a circle from the beginning because the coefficients of both x and y are the same positive values. And so I can leave it in circle form. X minus 1 squared plus the quantity y plus 2 squared equals 15 when I divide everything by 4. So important parts, the center is 1, negative 2. My radius is square root of 15 here. Okay, so that would be my circle in all of those values. So you can graph that. I'm not going to do the graphing for this one. And then same thing here when I separate the components. Now again, before I even get started, I should be able to identify this as a hyperbola because A, I have both x and y squared, and B, they have different signs. So I can complete the square here by adding 1 to the y. Here I'm going to take out the negative, which means I have to add 4 in here. Now again, because I added 1 into the y, I have to add 1 to this side. But because I added 4, and there's a negative in front, I actually have to take away 4. So this ends up kind of going directly into the hyperbola form. Y squared minus 2y plus 1 minus x squared minus 4x plus 4 equals 1. The 4's cancel, and we're just left with 1. And now when I factor, I get y minus 1 squared minus x minus 2 squared equals 1. So my center is at 2, 1. My slope of my asymptotes is just plus or minus 1. It's actually quite nice. And my foci would just be the square root of 1 plus 1, so it's root 2. So again, for my center, since this parabola opens up and down, because the y is positive, the foci coordinates are going to be 2, 1 plus or minus root 2. So in general, this is how the graph should look. 2, 1, so somewhere right about here. I go up 1 over 1 in both directions. And I create my dotted lines. Since it's up 1 and down 1, I create my hyperbola curves. And then finally, the equations of the asymptotes. Remember, we keep this pretty straightforward. We just use the equation of point slope form by substituting plus or minus slope. And so that would be the equations. If you choose to expand that more, that's fine. Not what you need to do, though. Now for number 10, find the lengths of the minor and major axes of an ellipse that can be drawn from a string of 8 feet long. I wouldn't worry too much about this question, but I will tell you how to do this. So it really basically tells me that the foci are 1 foot apart. That's really what that is telling me. There's this thing about an ellipse. Remember the definition I gave you that the distance from the two foci to any point, the sum of that distance is the same all around the ellipse. So that's what it's actually referring to by this string component here. But the idea is that the foci are one apart from each other. So again, if I was to plot this onto a coordinate grid, if this is the first foci, this is the second, and it's one apart and they're equally distant from the center, that means the center, we could put it 0, 0. What that means is that both of these is 1/2, 0 and negative 1/2, 0, right? Because the whole distance has to be 1 across. Now, because of that, we know that in the ellipse, that any of these distances, C and D, have to be equally the same. I'm going to pick a very specific point. I'm going to pick a point that's on the same axis, like this. And so what that really is going to tell me is two things. One, that this distance from here to here plus the same distance from here to here. I know it's really hard to see, but imagine this being from this point and then this point. We know that the sum of this has to be the same all the way around. And we're going to use the fact that this piece has to be here has to be a length of 1. So what that means, and the way I'm going to kind of break this down, is that if this piece is 1, that means this remaining piece here, and remember there's two parts to it, the top part and the bottom part, have to be equal to the remaining 8 feet. So the way I'm going to do this is I'm going to think about this circle, again the ellipse, and I'm going to draw my string from here to here, and then back to the other focus. That piece of string is 8, so I'm going to call the long part C, the small part D. So C plus D has to be 8. Now remember, C is this to this, which we know is 1, but it also has another D component. So I'm going to rewrite C as 1 plus D, and substitute that into the problem. And I get that D has to equal, 2D has to equal 7, and therefore D has to equal 3.5. Now that sounds kind of weird to do all that work, but what it actually is telling me is how much further the actual vertex is. So it's 1/2 here, right? So that means that this has to be another 3.5 feet out. So that means this vertex is actually at 4, 0, which would work the same thing on the other side. And that actually tells me the length of the first axis. The first axis has to be a length of 8. Okay, that's the major axis. Now to find the length of the other axis, it's actually a little bit easier now that we've done that component. That's actually the harder part. But now that we found it, we know that the sort of x radius here is 4. And we know that the focus distance is 1/2. So if you remember the equation of the focus is c squared equals a squared plus b squared, or I'm sorry, it's minus in an ellipse. We know that this is 1/2 squared. And remember, a is the larger radius. So 4 is the major axis, so that would be 4 squared minus b squared. So I get 1/4 equals 16 minus b squared. When I subtract the 16 from both sides, I get negative 63 over 4 equals negative b squared. Cancel out the negatives, 63 over 4 equals b squared, and therefore b equals root 63 over 2. Now again, b is just giving me the other vertex, root 63 over 2, and now the downward radius, negative root 63 over 2. Yeah, sorry. Which means the minor axis is both of them together, and so the minor axis is just root 63. Now these questions, there's a way to do these, but we did not get a chance to do this this year. So what I want you to do is just actually cross out the x, y components. There's this wonderful thing called eccentricity that deals with these components. We're not going to do that. I want you to be able to identify the equation without the x, y. So here, for example, 5x squared plus 5y squared, that has to be a circle. Same signs, same coefficients, that's it. Number 12 got cut down to here. X squared minus 3y squared. Again, you just have to go by what's there. This has to be a hyperbola in this case because it's a plus and a minus. They're different signs. Here I just have a y squared, so that's kind of a dead giveaway. It's a parabola. And here I have x squared and y squared, same signs, different coefficients. This one has to be an ellipse. Okay, and so in our last video, in the next one, we'll go through the parametric equations, and that'll be everything for this chapter. So I'll see you in the next one.